In this video, we'll quickly look at Atkinson's score. So we looked at box transformation in the last video, and then there should be some criteria that would allow us to understand whether it is necessary to apply box-cox transformation. And that utility is provided by Atkinson's score. This is just for the sake of mentioning the source. This is found in Princeton University course material by German projects, and I use that as a reference. So essentially, Atkinson's score gives us a utility that allows us to understand whether it is worthwhile to apply box-cox transformation. And a quick way to do that is to use the box-cox variable function. So I'll quickly calculate the Atkinson's coefficient by invoking a function called box-cox variable, and I'll pass a response variable as an input parameter. And this Atkinson coefficient is it's an additional variable, it's an auxiliary variable that needs to be included in your regression model, and it is to be explored whether it is significant. If it is significant, then perhaps we would need box-cox transformation. So that's the way to go about it. And what we'll quickly do is we will explore the values of Atkinson variable just for the sake of it, and then we can quickly put this back into our linear model. So I've added the Atkinson's as an additional input variable along with the three independent variables, which are humidity, wind speed, and temperature. So once I do that, my lambda for the box-cox transformation is computed as 1 minus Atkinson's coefficient, and we can quickly look at the value of this. I run this summary or LLF, and you can see that it is 0.97, and the p-value is quite low, t-value is high. That means it is significant, and that means we may still need to apply box-cox transformation. And the value of lambda would be 1 minus the Atkinson's coefficient would be roughly about 0.03. So that's already calculated here. So it's 0.029. Now it is close to 0. So one way is to apply the box-cox transformation, or we could also consider applying the logarithmic function and see the comparative difference. So in this case, I'm just doing the classical box-cox function application, and we can quickly see QQ plot against the normal distribution. And similarly, I could also do a simple logarithmic transformation and compare the results.